Hi, my name is Kaveh Karimadini, and I'll be presenting my part, task 3, the report one, which was a combination of uh, manually doing nearest neighbor search with BAB and skyline search with BAB. The key topics I'll be discussing in this presentation is how do we index our uh, data with R trees, and how do we use R trees for the BAB neighbor search for our query, nearest neighbor search, and how do we use uh, the BBS skyline search for finding the skyline points uh, for the trade-off of multi-criteria optimization, and also the divide and conquer part for each of the algorithms. First of all, what is an R-tree? An R-tree is a way of storing data, a large amount of data that stores each data in a minimum bounding rectangle, which these minimum bounding rectangles are minimized in terms of overlap and parameter, so that when you want to search for a point, it will be optimized in a way that we can prune those areas and not search those areas that do not overlap with the region query. How do we use the R tree for the branch and bound nearest neighbor search? Well, first of all, we plot the points and the query point inside scatter plot. And then after we plot, as you can see over here at the left diagram, and after we plotted it, we draw the minimum bounding rectangles first for the leaf node. It should be for only 2 or 3 points, as the B parameter is 3, except for the root, which is 1 element to 3 elements. And then if it is overflow, if it overflows, which it will, the 4 black rectangles inside the root will overflow. Then we have to draw the uh, bigger MBRs, the R6 and R5, so that it will fit the root, and then we build the R tree in a way that it is hierarchical, and the bigger MBRs are at the root, the medium ones will be at the intermediate level, and the points will be at the leaf. And then how can this BAB algorithm enhance nearest neighbor search for a query? First of all, when we do the BAB algorithm, we want to find a first nearest neighbor, or the p-best, inside a leaf node. After that, we can prune the MBRs after we backtrack from the current leaf that we found the nearest neighbor, and then prune the other regions that are less than the uh, current nearest neighbor. The step-by-step algorithm is in this diagram. First, we compute the distance from the root MBRs to the uh, query point, and then after that we go to the child uh, of that node, of the nearest node to the uh, query, and then we repeat the process until we reach the leaf node. After that, we are in the leaf node. We will uh, compute the distance between all the points inside the leaf node to the query point, and the least one will be the p-best, the nearest neighbor, the current nearest neighbor, and then repeat these steps from 1 to 4 until we find uh, the nearest neighbor for the entire tree. Of course, we backtrack and see if any other nodes will be will have a lesser distance from the uh, p best. The divide and conquer is in a way that we divide the x-axis into two. The left hand side and the right hand side will be done separately for the BAB algorithm, and the construction of the R tree is done separately, and then we combine them by getting the minimum of the p best for the left hand side and the p best for the right hand side. And finally, we want to talk about the skyline search. The skyline search is an algorithm that returns points that are not dominated by others. Domination is it means that a point is dominating another point if it is lesser in both dimensions, in both axes, or strictly in one axis. And then after we remove all the uh, dominated points, the remaining points are the representation of our optimal trade-off between multiple criteria. So basically how the skyline search is done is in a way that we calculate the MBRs from the root to the origin point, meaning the x-axis 0 and the y-axis 0, and then the distances alongside the IDs will be stored inside a queue H, and then we will we will pop the first element and insert the child nodes or points if it is a leaf node inside the H queue. After that, we will see the sorted list. If it is a point, then we'll pop the point and then store it in the our current skyline list. And after that, we will, each time we want to pop a point and see if it is, if the and after that, if we pop a point with the minimum distance inside the HQ, what we will do is that we compare the dominance of the current skyline and the popped point, see if that the skyline points dominate the popped point or not. If it doesn't, then we'll add it to the current skyline. We will do this process recursively until all the skylines are found and the HQ will be empty. And then we will divide for the divide and conquer. We will divide the x-axis into two and then build an R tree for the left hand side and the right hand side, and do the BBS algorithm in the previous slide on the left hand side and the right hand side, and then find the skyline for the left and the right. After that, we will build an one-dimensional dominant screening line and place the points on the line if the points that are placed must be the coordinates of the y-axis, as the left skyline is 100% the skyline as it dominates in x-axis. But the right skyline, we must check the y-axis is if it is dominated by the left axis in the y-axis. And this line will show us if the line is the y-axis. We can see that P5, which is in the right skyline, is dominated by P6, P8, and P14, which must be excluded from the skyline. And the final skyline will be P15, P12, P10, P6, P8, and P14. Thank you.